Let's try a few examples. Remember to pause if you need to so you can have a think about them. Here is another distance-time graph. Can you tell how far this object moved, how long it took to move, and also what speed it was moving at? It's a straight line, so we know that the speed is constant. On the graph, we can see that the line stops when the time is at 4 seconds on the x-axis. And at that time, the line has risen to 40 meters on the y-axis. So the object traveled 40 meters in 4 seconds. We take that 40 meters rise and divide it by the 4 seconds, that's rise over run, and that gives us the gradient of the graph, which is the speed. So the speed is 40 divided by 4, or 10 meters per second. So if this graph is of a person running, then they are almost as fast as Usain Bolt, the world record holder. As an extra question here, if this object kept moving at the same speed for another 8 seconds, what would the total distance be? After another 8 seconds, then the object will have been moving for 12 seconds total. So 12 seconds at a speed of 10 meters every second is 12 times 10, 120 meters. We could see that on the graph if we continued the line up and if we had space to plot it. If you look carefully at the units on this calculation, you can see that the seconds of time cancel with the per seconds of speed, and so we're left with just meters of distance for our answer. Let's try another one. What is the time, distance, and speed that is shown on this graph? The graph goes along the x-axis for 6 seconds, and at the end of that 6 seconds, it has risen 15 meters on the y-axis. So we divide the 15-meter rise by the 6-second run, and that gives us a speed of 2.5 meters per second. And again, if this object moved for another 10 seconds, how far would it have moved altogether? So our initial 6 seconds plus another 10 seconds is 16 seconds. 16 seconds times 2.5 meters per second is 40 meters. So we can see that even though this object is moving for longer, it does not go as far as our last example because it is slower. This makes sense. Be careful looking at this one. What are the time, distance, and speed here? If you are looking carefully, then you'll see that the scale on this graph has changed. So the graph goes along the x-axis for 6 seconds again, and it goes up the y-axis for 15 meters again. So the speed here will be exactly the same as the last example, 2.5 meters per second. You have to pay attention to the scale on graphs because the same graph can look very different if you change the numbers on the bottom and up the side. Sometimes people will use this to trick you. Watch out. Let's try one more. What do you think the time, distance, and speed of this object is? Take a moment if you need to. Just use the same ideas as before, but there's something different here, isn't there? This graph is running for 6 seconds along the x-axis, but in that 6 seconds, it doesn't go up at all. The distance is 0, and 0 divided by 6 is 0. So this speed is 0 meters per second. The object is not moving, and the gradient of the line is 0. While we're here, I'll point out I could also draw this line on the graph. This object is also not moving, but it's not moving at 40 meters. What does that mean? It means we need to know where 0 meters is, and that makes things a bit more complicated. We may look at this in a later video, but it goes back to the ideas of velocity and direction that we mentioned before. Hi there, hope you enjoyed the video. Like, comment, subscribe, etc. If you prefer longer videos, you can find the full versions of these lessons on our other channel, which is just up there. But no matter what, please keep learning something, because no matter who you are or how old you are, every day is a school day. Bye for now.